All right, guys, welcome back to Geometry, Lesson 1-2. Today we're going to be talking about more geometric figures, so even more vocab, describing angle and angle pairs. And then we're going to be talking about identifying names in parts of circles. So those are going to be a little bit more definition. Okay, what you're going to need today is your Springboard book, a pen or a pencil, and again, if you want a highlighter, that could be helpful too. So let's get started here. So what we're going to be doing, there's our targets again. Okay, naming angles is where we're starting with on page 7. So they want us to describe 4 angles with different characteristics, describe each angle, and name the angle using numbers and letters. So before we actually do that, I'm going to have you guys skip to the next page on page 8, because here is where they name all the types of angles and how you can draw them or write them or think about them. So the first one is an acute angle. So acute angles measure greater than 0 but less than 90. So an acute angle is a pretty small angle. It's not very wide. Okay, a right angle measures 90 degrees. And then we have an obtuse angle. Obtuse angles are angles that are bigger than 90 degrees but not quite 180 degrees. Okay, and then a straight angle measures 180 degrees. So a straight angle is just that, it's a straight line. Okay, so if I go back here to these 4 angles and I draw and name them, the first one we had was an acute angle. So remember an acute angle, and I'm just going to call this angle A. Okay, is an angle that the angle is less than 90 degrees. So that's a pretty small angle right there. Okay, so we'll just call this angle A. If we wanted to give it a number, okay, we could give it a number and call it angle 1 also. Okay. The next angle they talked about was a right angle. So if I have a right angle, they're usually going to denote that it's a right angle by using a little box in the corner. So that's how they'll tell you if something is 90 degrees or a right angle, it should have that little box in the corner there. And I'm going to call this angle R for right angle. Or if we wanted to give it a number, we could give it a number as angle 2. The third angle they talked about there was the obtuse angle. So an obtuse angle is bigger than 90, but not quite 180. So if I do an angle like this, so I'm going to call this angle O for obtuse. So as you see, it's not quite a straight line like the 90-degree angle. It's a little wider than that. So that would be an example of an obtuse angle. And then the last one we have is what they would call a straight angle. And a straight angle looks like a straight line. Okay. I'm going to call this, we'll give it 3 points here. I'm going to call it SRT for straight. Okay. So one way I can name this angle using that, there's not really a vertex here, but I'll just go in the order here. SRT. Or if I name it using a number, I can call that angle 4. Now, I know that kind of looks like a line, but really, in this case, we're referring to it in the terms of an angle. So that's why we have to use the angle symbol when we're talking about it. Okay, so there's our 4 different kinds of angles there. So now what they're going to have us do in the next part is compare and contrast each set of angles. So if I look at 2A here, I notice that I have an acute angle. But then I also have this obtuse angle. So that's how they're different if I am contrasting them. But if I can see, if I connect these angles all together, well, what would that make? It's going to make a straight line. So we have a couple vocab here that we're going to talk about that I have under these little boxes. But if we're talking, so we already said angle 1 is acute, angle 2 is obtuse, which we have here. Angle 1 is acute, angle 2 is obtuse. What they're also calling these angles are supplementary and adjacent. So let's talk about what that means. So first definition, and you should probably write this in your Springboard book so you have all the definitions there, is something that they would call an adjacent angle. And adjacent just means next to. So they're next to each other. They have a common vertex. Okay, if they look at this vertex here, they share that vertex in common, and they have a common side, this ray right here that's coming out of there. So angle 1 uses that side, and so does angle 2. So it's a common vertex and a common side. So let's see, they're calling that adjacent. Okay, the other thing they are is supplementary. Okay, so here's that definition. Supplementary. Those are angles that create a straight angle when you put them together. So if I add angle 1 to angle 2, they make a straight angle, that red line that went all the way across. So this just means that the two angles add to 180 degrees. That's what makes them supplementary. Okay? So that's how we can kind of compare and contrast those. Let's look at B. So in B, again, we have two acute angles. We have an acute angle here and an acute angle here. So these, again, would be adjacent because they're sharing that vertex D and that segment DB or BD. So they're also adjacent, but since these two angles formed a 90 degree, we would call those complementary angles. So they are adjacent because they are connected to each other, they're next to each other, but they are what we would call complementary. So here's the definition for complementary angles. Those are angles that create a right angle when you put them together. Or if you added their angle measurements, they would add to 90 degrees. Okay? So make sure you're writing these vocab words in. If you have to pause the video to do that, then I would do it. So that way you have all those vocabulary terms together. Okay. Now, if we look at C and D, those problems are not adjacent. They're separate angles. Okay, they're not next to each other. They don't share any common points or sides. So they're not adjacent, neither of them. But take a guess. Okay, if angle DEF is 30 degrees and angle RST is 60 degrees, we would call those complementary. And again, not adjacent because they are not together. They're not next to each other. Okay. And then we have angle DEF, comparing that with angle XYZ. I have a 30 degree angle with a 150 degree angle. We would say that those are supplementary. If I add those two measurements, I should get 180 degrees. Okay. So again, lots of vocab again here, but just kind of naming our angles a little better. Okay. So there's those definitions again, complementary and supplementary. So it says the figure below shows two intersecting lines. Name two angles that are supplementary to angle 4. So let's mark angle 4 here. Use a highlighter. There's angle 4. So they want to know what two angles are supplementary to that angle. Well, if I'm looking at my picture, remember supplementary would form a straight line. So what angle with number 4 would form a straight line? We have this angle here. So angle 3 would be supplementary. But we also have this angle here. This could give us a straight line also. So we have angle 5 here. Okay. Now, if we think about this a little closely also, okay, angles 3 and 5 are also supplementary to angle 6. So I'm just going to put a little note here on the side here. They didn't ask us this, but I'm going to abbreviate there, sup for supplementary. So they're also supplementary to angle 6 because angle 6 and 3 would form a straight line. So would 6 and 5. They would also form a straight line. So those ones are also supplementary. So if we think about it in terms of that, that leads us to question B. Explain why the angles you named in part A must have the same measure. So they're saying, why do angles 3 and 5 have the same measure? So I'm going to erase all this so we can see our angles again. Okay, so let's think of it like this. I'm just going to draw two different lines here. And I'm just going to put some numbers in there just for the fun of it. So here's my angle 4. So if I said that angle 4 was, let's say, make it easy on ourselves, 100 degrees. So that means we have angle 3 and angle 5. So if those angles are supplementary to angle 4, they have to add to 180. So this would have to be 80 degrees. But then we said angles 4 and 5 were also supplementary. So that would also have to be 80 degrees. And then since we kind of added that side note in that those angles would be supplementary also to angle 6, well, that means that angle 6 has to be 100 degrees also. So what we have here is a term that we're not going to necessarily learn yet for another couple of sections, but these are called vertical angles. What vertical angles mean, angles that are opposite of each other, vertical of each other. So like say angle 3 and angle 5. And I'll use a different color. Angles 4 and angle 6. Anytime they're opposite of each other, they're going to have the same measure. Okay, so that's what vertical angles mean. So we're not going to necessarily learn that in depth too much yet, but it's worth pointing out. Okay. All right, we're going to move on from this table because we kind of already talked about it a lot. So then we're going to move on to parts of a circle. So different circle vocab here. So our three main ones we're going to talk about today are what is called a chord, a diameter, and a radius. So in this circle, we're going to draw and label each geometric term. So we have a radius OA. So if I look back at what we would call a radius, the radius is a segment with one endpoint on the center of the circle and one endpoint at the, so one endpoint on the circle, excuse me, and one endpoint at the center of the circle. So here's my center. And then we need one endpoint on the end of the circle. So if I connect those, that would be a radius. So we'll call this OA. So that's what a radius is. It starts at the center, it goes out to the edge of the circle. If we wanted to label a chord, okay, a chord BA. So a chord of a circle is a segment with both endpoints on the circle. So meaning like on the perimeter of the circle, both those endpoints are on there. Now they're using A again, so I'm going to use this same point. So I can just put my B anywhere on the edge of a circle and connect those. So this would be BA. So that would be what a chord is. It goes through the circle, hitting two endpoints. They can be anywhere on the circle. Okay, the last one is the diameter. And the diameter is a chord that passes through the center of the circle. So remember, a chord has its endpoints on both edges of the circle, on the perimeter of the circle. But this one's special because it has to pass through the center in order to be considered a diameter. So if we have to do diameter CA, we're using this endpoint A, and it has to pass through the center and then hit the other edge of the circle. So a diameter we kind of can think of as like a really long radius, right? Because it's two radii put together. It goes through the center of the circle and it goes the whole width of that circle. Okay. So again, a radius only goes from the center out. Diameter goes from end to end, passing through the center. And then a chord is just, it has two endpoints on the edge of the circle. Now, if I look at my drawing, refer to your drawing in the circle above. What is the geometric term for point O? So right here, point O. What would we call that point? Hopefully, you said that point O is our center. It's our center of the circle. Okay? Passes through the center. Center. Okay. All right, last thing we're going to talk about here is another little vocab word. The circles below are concentric, meaning they have the same center. So let me get a highlighter there to highlight that vocab word. So concentric circles are just basically, it's a circle within a circle. Okay, you can also refer to that as kind of like a bullseye, okay, like a dartboard right there. So you have an outer circle, inner circles. There could be more than two, doesn't only have to be two. So in this case, we have two concentric circles with a center at point P. Okay, so explain why circle P is not an appropriate name for the smaller circle. So if we call this circle point P, because we're naming the circle based on its center, that's fine, but both of these circles share that center point. So if I just said circle P, it's not very clear which circle I'm talking about, right? So let's write that in. So circle P could be referring to either circle. So if I use circle P, it's not really an appropriate way to do it. So instead, an alternate way to name these concentric circles is to use the radii. So for example, this smaller circle here, I can call this circle P, but I would have to say with radii Q or PQ. Okay, so I'm specifying that it's using this circle with this radius. If I wanted to be referring to the larger outer circle, then I can do that. I can call this circle P, but I have to justify it or use an alternative way to specify which circle I'm talking about. So I would just say with radii PR. Okay, so both ways, and again, you could name it circle P, but in this case, since there's two circles, we have to kind of specify with the radii which one we're actually talking about. Okay, so again, lots more vocab today we learned. Okay, a lot of vocab with circles, so chord, diameter, and radii or radius. Okay, knowing what those are on a circle. And then all of our terms for the angles: acute, right angle, obtuse, a straight angle, and then also complementary and supplementary. So a lot of vocab here. We want to make sure we're nailing this vocab because that's what's going to be the backbone for all of our courses here as we move forward in geometry. Okay, so that's lesson 1, 2. I'll see you for the next one. See you guys.